So at this point, you're probably wondering, what is entropy? Well, the best definition of entropy was given by Boltzmann. So let's just jump right into Boltzmann's definition of entropy. So entropy is equal to Boltzmann's constant times the log of W. Well, what are both of those things? So first, let's do Boltzmann's constant. Boltzmann's constant is just 1.38 times 10 to the negative 23rd joules per Kelvin. You can come up with a value of, if you just need Boltzmann's constant, you can come up with it yourself. It is just the universal gas constant divided by Avogadro's number. So it's sort of a universal gas constant per molecule. You can think of it that way instead of being per mole. All right, what about W? W is going to be a little more interesting. W is the number of microstates in a macrostate. So we're going to have to define both of those. So let's go ahead and define both of those. So first of all, a macrostate, and this is the macrostate is the one that's going to be more familiar to you because we've been talking about macrostates all the time in this quarter. It's basically defined by the pressure, volume, temperature, and composition of a system. So if I say there's a glass of water and it's got 18 mils and it's at 1 bar and 25 degrees C, you know the macrostate of the system. So it's something we can see it just at the macro level. A microstate is completely different. What would we have to know the microstate? Well, to know the microstate, we'd have to know all the quantum states of all the molecules in the system. And that's a lot of information. So knowing a microstate, you're knowing a lot more than you do with a macrostate. So you'd have to know, for instance, the vibrational, rotational, and translational quantum numbers of all the system. So basically, in a classical mechanics sense, what this would mean is if we wanted to know the microstate of the gas atoms in this room, we'd have to know where all of them were, how fast they were going, how fast each of them were rotating, and how fast each of them were vibrating. Okay, so you can see that there's more than one microstate in most macrostates. So we could say most macrostates contain many microstates. And another way of saying that is that W is going to be large, right? Since W is the number of macrostates in a number of microstates in a particular macrostate. Let's look at a specific example. Let's try to calculate the value of W at absolute zero. So at t equal to 0. Well, if t is absolute 0, then every molecule is in its lowest possible quantum state, its lowest energy quantum state. And so we can say every molecule is in the lowest quantum state, just by virtue of being at absolute 0. Oops, there we go. So if every molecule in its lowest quantum state, we can ask how many different ways of doing that are there? In other words, is there more than one microstate that's compatible with this statement? No. there's only one microstate where every molecule is in its lowest quantum state. We just say everything is in its lowest quantum number. We've described, therefore, one microstate. So this is only one microstate. So if this is only one possible microstate, then we can say, aha, W is equal to 1. There's only one possible, so absolute 0, that's describing the macrostate, but we've just proven that there's only one microstate that is compatible with that macrostate. So since entropy is Boltzmann's constant times the log of W, we can see that entropy at t equals 0 is going to be equal to 0. And that's the third law of thermodynamics, that the entropy of any system will go to 0 at absolute 0. There is, well, actually there are a few exceptions to this, and this would be states where the orientation of the molecules can be, there's more than one possible for the orientation of molecules when they're at absolute 0. And your book gives the example of carbon monoxide. And so in that case, there's more than, since there's more than one orientation, W is not quite equal to 1, and so entropy is a little bit higher than 0. That's called residual entropy. Let's write that word over here. Hospital. So you can read about that in Atkins.